Welcome back, dear students. In the previous session we discussed about hybridization. We introduced the concept of hybridization and discussed about SP, SP2 and SP3 hybridization. And in this lecture we will discuss upon SP3D, SP3D2, SP3D3 and DSP2 type of hybridization. Okay, now let's begin. Let's begin with DSP2 hybridization. See, here we are writing DSP2 hybridization, the intermixing of dx square minus y square orbital and an s orbital and two p orbitals to form four equivalent orbitals is known as DSP2 hybridization or DSP2 orbitals. Okay, so in this type of hybridization, it involves d orbital, one d orbital in the penultimate shell, and s orbital and two p orbitals, and they undergo intermixing and form new orbitals of equivalent, new hybrid orbitals of equivalent energy and identical shape, and they are oriented in a square planar fashion. Okay, these hybrid orbitals are oriented in a square planar fashion. Here you can see that four hybrid orbitals are newly created, but in the case of sp3 hybridization also four hybrid orbitals are created, but the structure is different. That is, in that case it is tetrahedral in nature, but in the case of DSP2 hybridization, even though it contains four hybrid orbitals, it is arranged in a square planar way. Okay, now they are making a bond angle of 90 degree. Example is cuprammonium complex. This is the example, cuprammonium complex. Let's see how it takes place. This is an example of coordination compound. Okay, so in this case, this is the molecular formula of cuprammonium complex. Here copper, we know that the atomic number of copper is 29, and here the electronic configuration of copper is 3d10, 4s1 and 4p orbit, 4p vacant, 4p. Okay, so there is only one electron is occupied in the 4s orbital. Okay, it's unpaired electron. Now but in cuprammonium complex, copper exists in the +2 oxidation state. So in the +2 oxidation state, copper has an electronic configuration like this. And during the formation of this complex, what happens is one of the electron, here there is one unpaired electron, and that unpaired electron get promoted to the p orbital. Okay, p orbital, and four orbitals made unpaired or not unpaired. These are the empty orbitals. Okay, there are four empty orbitals now. And what happens is this 3d orbital, one of the 3d orbital, that is 3dx square minus y square, and a 4s orbital and 4p orbital, two of the 4p orbitals get hybridized and form 4 DSP2 hybrid orbitals. Okay, and in this I already mentioned that these orbitals are empty orbitals. So this ammonia, we know that ammonia contains a lone pair of electrons, and this lone pair of electron was donated to this empty, or by using this lone pair of electrons of ammonia, it form complexes, or it form coordinate bond with a Cu2 plus ion. So these are the electrons coming from the ammonia molecule. This is contributed by these electrons are contributed by ammonia molecule. So this is contributed by one ammonia molecule, another ammonia, and this one was contributed by another ammonia. Okay, so 4 electron pair from ammonia molecule makes the this cuprammonium complex has dsp2 hybridization having square planar structure, and due to the presence of unpaired electron, the system was found to be paramagnetic in nature. That means the complex shows magnetic behavior. Why? Because of the presence of unpaired electron. So the structure is square planar. Sorry. I can write like this: ammonia, since, and this ammonia, this is ammonia, and since this is coordinated, can draw like this. Okay, coordinate bond, and they are the shape is square planar and the bond angle is 90 degree. Okay, now the second type of hybridization is sp3d hybridization. Here, intermixing of one s orbital, 3 p orbitals and one d orbital of the valency shell of an atom to form 5 identical orbitals, called the sp3d hybridization. The resulting orbitals are called the sp3d hybrid orbitals. They have trigonal bipyramidal geometry, and in the case of sp3d hybridization, we can identify, we can see two types of bonds. That is, one is known as equatorial bonds and the other one is known as axial bonds. And in the case of this sp3 hybridized molecule, the equatorial bonds makes a bond angle of 120 degree and the axial bonds makes an angle of 90 degree with each other. See, this is the example PCl5. See, this is the electronic configuration, ground state electronic configuration of phosphorus. That is 1s2, 2s2, 2p6, 3s2, 3p3, and there are 3 empty 3d orbitals. Okay, and in the excited state, what happens is one of the electron in the 3s orbital get promoted to vacant 3d orbital. Okay, one of the electron in the s2 or 3s orbital get promoted to the or get excited to the 3d orbital, and now the electronic configuration becomes like this: 3s1, 3p3 and 3d1, and 1 3s orbital, 3p orbital and 1 3d orbital get hybridized to form 5 sp3d hybrid orbitals of equivalent energy and identical shape. Then what happens? Then it will pair with, or it will overlap. These hybrid orbitals are directed towards the corners of a regular bipyramid, triangular bipyramid. Okay, so after that, chlorine atom, one electron from the chlorine atom was used to pair with these hybrid orbitals, okay, and forms PCl bonds. These bonds are called, that is, this is the plane of the molecule PCl3, this is the plane, and these bonds are known as equatorial bonds. And these equatorial bonds makes an angle of 120 degree with each other. These equatorial bonds makes an angle of 120 with each other, while these are known as the axial bonds, PCl. These perpendicular bonds are known as axial bonds. This will make an angle of 90 degrees. Okay. Now let's see sp3d2 hybridization. Here, the intermixing of one s orbital, 3 p orbitals and 2 d orbitals of the valence shell of an atom to form 6 sp3d2 hybrid orbitals of identical shape and of equivalent energies. They have regular octahedron geometry, and making an angle of 90 degree with each other. There is no restriction between equatorial and axial bond. There is no difference between equatorial bonds and axial bonds. Example is SF6. Here you can see the ground state electronic configuration of sulfur, that is 3s2, 3p4, and there are vacant 3d orbitals. And in the presence of fluorine atom, what happens? Sulfur get excited, and during excitation, electrons from 3s and 3p orbitals get excited to the vacant 3d orbital, and 1 3s and 3 3p orbitals and 2 3d orbitals hybridized to form 6 sp3d2 hybridized orbitals, and these hybrid orbitals are directed towards the corners of a regular octahedron. And the hybrid orbitals then overlap with the pz orbital of fluorine atoms, forms 6 sigma bonds. This is the structure of SF6. The pink color ball represents sulfur, and the white color balls represents fluorine. Now let's see the fourth type of hybridization, that is sp3d3 hybridization. Here intermixing of 1 s orbital, 3 p orbitals and 3 d orbitals of the valence shell of the atom to form 7 identical orbitals, and the process is known as sp3d3 hybridization. Here the geometry is pentagonal bipyramidal, and here you can see difference between equatorial bonds and axial bonds. Equatorial bonds makes an angle of 172 degrees and axial bonds makes an angle of 90 degrees. An example is IF7, that is iodine heptafluoride. This is a ground state electronic configuration of the of iodine, that is 5s2, 5p7 and 5p5, 3 empty 3d orbital. And during excitation, these three home orbitals get unpaired, and three of these electrons get excited to 5d orbitals, and these 7 orbitals, atomic orbitals, hybridized to form 7 sp3d3 hybridized orbitals of equivalent energy and identical shape. They are directed towards the corners of a pentagonal bipyramid. Okay, and this is the geometry of this IF7 molecule. These are the equatorial bonds, and this one makes an angle of 72 degree, and axial bond and equatorial, this one represents 90 degrees. So there is a plane of 5 atoms, and above and below that 2 fluorine atom occupies the space. So let's summarize the hybridization like this, that is sp2 hybridization. It is linear in shape, making a bond angle of 180 degree. Then sp2 hybridization, it is triangular planar structure and the bond angle is 120. sp3 hybridization, the structure is tetrahedral in nature and bond angle is 109.5 degrees or 109 degree 28 minutes. sp3d hybridization, it is trigonal bipyramidal in nature, and there is difference between equatorial and axial bonds, and these are the bond angles. And octahedron is also a highly symmetric molecule, and they exhibit hybridization of sp3d2 and makes all bonds makes an angle of 90 degree with each other. There is one more structure is there, that is sp3d3 hybridization, and the structure is pentagonal bipyramidal, and there is difference between equatorial and axial bonds. So Hope you understood the concept of hybridization very well. Thank you.